Yeah, good morning, one and all present here. Myself, Dr. P. Janagarathinam, Assistant Professor, Department of Mechanical Engineering. In my previous video series, I already discussed about the Kirchhoff's law and other four-bar linkages and other mechanisms. Today, I am going to discuss about the mobility and coincident, what are the different types of joints, links, and how we are applying the Grueblers criterion or equation into our mechanisms and all. Today I am going to discuss. So understanding of mobility and coincident joints and group equations. First of all, what is meant by degrees of freedom or mobility? A mobility or degrees of freedom quantifies the independent inputs are required to control a mechanisms or movement. For example, we have to consider the single degrees of freedom means we have to consider only one axis of rotations. We have to consider the three axis of 3 degrees of freedom means we have to consider all these three axes for making the rotations. So 3D body examples are a rigid body in 3D space like 6 degrees of freedoms, like 3 for translation motions and 3 for an rotational motions. So like pitch, yaw and roll. We have to discuss elaborately about the different gyroscopic effects of chips, boards and all discussed in our third unit. So next is planar mechanism. In planar mechanisms, mobility defines the number of independent parameters required to specify the system's configurations or the mechanism. So this is the coincident joints. When multiple joints are the same location means the coincident joints occur. Two or more joints physically connect at the exact same point along the same axis. So next one is for constraint impact. These arrangements can reduce the effective degrees of freedom by introducing the additional and other constraints. Mobility implication means understanding of coincidence joints in a crucial complex linkages as their arrangements are significantly influences the overall mobility. So this is the gentle Gruebeler equations we have to use for the planar mechanisms like m is equal to 3 into n minus 1 minus 2 j1 minus j2. Here the n is nothing but number of links which is including the ground links. And next one is for J1 means full joints, degrees of freedoms. We have to consider the revolute and prismatic joints. And J2 means the hop joints, which means the cams and gears. So this is the Gruebeler criterions. And visualizing the Gruebeler equations for a 4-bar linkage, there are total number of links 4, including the fixed ground link. And for revolute joints, each providing the 1 degrees of freedom, and hop joints are 0 because in our 4-bar linkage there is no cam or gears present. And so the mobility calculations m is equal to 3 into n minus 1, number of links 4, and minus 2 into full joints are 4, so which is equal to 1. So the 4-bar linkages has 1 degrees of freedom. So the Gruebeler criterions which will be used to calculate the number of degrees of freedoms which will be present in their different planar mechanisms. In this example, we have to consider the 4-bar linkage. So 4-bar linkage only we are having the 1 degrees of freedom, which means the link rotating the crank based mechanisms. So this is the sum of other mechanism and their calculations of mobility. We have to take the slider crank mechanism means the mobility value is 1, and gear mechanisms also having the degrees of freedoms equal to 1, and the locked structure mechanisms we are having only 0 degrees of freedom because locked structure means it is a fixed body, so there is no movement, so there is no degrees of freedom, which is a stable structure, which is a rigid body. So this is the why mobility matters design the fundamental mechanisms, because the fundamental mechanisms are functional mechanisms which will be developed by using this kind of mobility. So directly determines the number of actuators and what are the constraints and avoiding the design flaws. By we are not using the Gruebeler criterion means some of the flaws will be acquired means the entire systems will be collapsed. So due to that unavoidable flaws, we have to use this kind of Gruebeler criterions to make the good and constrained mechanisms. So this is the coincident joints impact on mobility calculations. Here also some of the we have to do the some of the design analysis, which may be ensure that the mobility prediction and the mechanisms will be functioned, and the different types of joints and links are elaborately incorporated, and it may be reductions may be occurred in that constraints. So this is the real-time case study. Like stamping mechanisms, we have to choose and means the mobility value is 1. Here the 7 full joints, the number of links equal to 7. This is the case study we have to choose, and like real world applications of stamping machines. Here the number of full joints are 7, number of links are 6, and the half joints are 0. We have to do the mobility calculations. We will get the number of degrees of freedom or mobility value will be equal to 1. So this is the summary. Today we have to discuss about the mobility, design mastery, and coincident joints group equations. So this is the small mind map which will be developed for today's class. Formulas, kinematic, pass, mechanism examples. We are having the different mechanisms. Based on the different working mechanisms, we have to incorporate the different degrees of freedoms and structures and mechanisms. So this is the two assessment questions. Based on their design, we have to calculate the mobility values. So planar mechanisms, we are having the number of degrees of freedom C will be equal to 0, and the lower per example is a rolling cylinder on a flat surface. So this is the sum of the reference I have to refer to make this kind of PPT. So thank you. In our next video series, I already next series I discussed about the different mechanisms and other topics. Thank you.